So yesterday we talked about stoichiometry and how to figure out how much reactant you need to make how much product. Today we're refining our skills a little bit and we're talking about limiting an excess reactants. Here is the big deal. The name is limiting an excess reactant. Make sure the one that you're choosing, the one you're calculating, is indeed a reactant. It would be very useful to know, given a certain set of circumstances, which one of the reactants is going to run out first. The limiting reactant is truly that which runs out first. That's the definition. An excess reactant is the one that's left over. Warning, you might have more than one excess reactant. It could be in some weird circumstance that you had two limiting reactants. That would be really difficult to engineer. Probably isn't going to happen. All right, so this is another case where it's easier to show than tell. And I'm going back to the ratio method that you learned in Chem 1 because it's just so easy to do. You can do it dimensionally, and I welcome you to do it, but if you don't want to, this is really easy. All right. Here's our problem. We have that 27 grams of hydrogen gas, and to it we're going to add 15 grams of oxygen gas to form water. A typical problem would ask how much water is going to be produced, which one of the reactants will run out first, which one is left over, and how much is left over, and the mass of water that should be produced, which seems to me is just like that one, so we'll ignore it. All right. So the first thing you do is the first thing you do in any chemistry problem, start with the balanced equation. Here it is. The second thing you need to do is identify from the problem what is given, 27 grams of hydrogen gas and 15 grams of oxygen gas, and what you would like to know, the amount of water formed. So this should be X grams. All right, now we're going to use a set of ratios. The first ratio that we could use is a mole ratio, and it is nothing more than the coefficients from the balanced equation. The mass ratio is the coefficient times the molar mass of the compound. The molar mass, 32, times the coefficient 1. 18 grams in 1 mole of water. There are 2 moles in this balanced equation. That would be 36. Then we just set up a set of ratios. So the first thing I'm going to do is this. I'm going to test the hydrogen gas and see how much water it should produce. Then I'm going to test the oxygen gas and see how much water it should produce. The one that produces the least amount of product is the limiting reactant. So to do that, I'm using the values from my chart. I have 27 grams of hydrogen. How much water will that make? Divided by its ratios, mass ratios. And I can see that when the hydrogen gives out, 243 grams of water will be produced. Meanwhile, I'll do the same thing with the oxygen. 15 grams of oxygen over its mass ratio equals how many grams of water over its mass ratio? 16.8 grams of water will be produced before the oxygen runs out. The limiting reactant is therefore the one that produces the least amount of product. That would be the oxygen. This gives you 2 questions answered. It tells you the limiting reactant, which is oxygen, and the mass of water that is produced, 16.8 grams. You must remember that when the limiting reactant runs out, you can no longer make water. There's always oxygen in water, and when you run out, there's no more water produced. So the reaction, in effect, stops when you run out of the limiting reactant. However, you do need to know that some of the excess reactant, the hydrogen, is tied up in the water, correct? 16.8 grams of water were made, and some of it contains part of the 27 grams of hydrogen that we started with. How much is tied up in the water? It's the same kind of calculation. The excess reactant used. How many grams of hydrogen were used in making 16.8 grams of water? Divided by its mass factor, cross multiply. 1.9 grams of water is tied up in 16.8 grams of, 1.9 grams of hydrogen is tied up in 16.8 grams of water. How much is left over? I started with 27 grams. I used 1.9 grams making some water. Therefore, I have 25.1 grams left over. Easy? One more concept and then we're just going to practice. You know, in that mole relationship lab that is pending, which by the way is due October 2nd, one of the things I asked you to calculate was the theoretical yield. The theoretical yield is a calculation. You might want to put a note on there, always a calculation. The theoretical yield is if you, the perfect chemist, in a perfect laboratory, under perfect conditions, with perfect technique, made some product. You are not perfect, the lab's not perfect, conditions are never perfect. So what you make, you actually experimentally get, is your actual yield. To find the percent yield, you take the actual yield, the amount that you measured and got from your experiment, over your theoretical yield, what you calculated, times 100%. The closer you are to 100, the closer you are to perfection. Now, one thing that you have to remember is there is no way that your percent yield can be over 100%. You can't get more than is theoretically possible. Are you understanding that bit? Okay, that'll work really well until you try to do your calculations for that mole lab, because we have a lot of contaminants. Okay.